Okay. Thanks everybody for coming to this session, last session of the day, so I'm sure we're all tired and also really excited to get to the next bit of the conference. Just as a quick show of hands, who would consider themselves to be a full stack developer? Full stack, okay, quite a few. Anybody just consider themselves back end? Couple. And then anyone just front end? And then any non-developers? I just want to make sure. All right, go. All right. So if you consider yourself full stack, hopefully I can take some of the lessons that we've learned doing back end and apply them to front end. If you're just back end, hopefully I can help make the front end a little less scary. And if you're front end, hopefully I can provide what I think is a unique alternative to some of the more popular ways of managing state. A little about me. My name is Sam Ferree. I'm a senior software engineer and tech lead for Winona IT. We're a consulting firm in the middle of a cornfield between Chicago and Detroit. If you ever need any custom software or managed IT services, look us up. I do tweet mostly strong software opinions, but if it's fall in the northern hemisphere, I will be tweeting strong college football opinions. So if I seem really angry on some Sunday, that's why. I have a blog. I haven't been able to write as much as I would like to recently, but there is some stuff there you can read. And if I have anything horribly, horribly wrong, please let me know. Appreciate it. I'll talk a little bit about my journey to building component-based web UIs. I was building WinForms applications in the early 2000s. For anybody who doesn't know, this is just like a secret handshake to let other .NET developers know how old we are. Not quite into the VB6 table, but I do start here. I start at WinForms. From then, I made a switch to Java, building UIs with a library called Swing. I did this mainly because the person who was paying me wanted me to. And then from there, I made the reach technically to web apps by using a technology called JSF, or Java Servlet Faces. Tried very hard to make you feel like you weren't writing a web application. Did not look like the web applications that we build today. But it was technically a web app. Then when .NET decided they were going to move kind of away from this special little Microsoft toy to cross-platform, open source, and all that good stuff, I kind of put all my chips back on .NET, wanted to get back into the .NET space, always been a big fan of C#. But the main titans of the front end those days was Angular and React, and of the two I found Angular to be a little bit more palatable. Probably still to this day. And then not too much longer after that, our keynote speaker that we heard this morning threw me a lifeline, saved me, gave us all Blazor. So I am a happy C# developer getting to write it both on the front end and the back end now. So in these last two, kind of this Angular and this Blazor time frame is where I started kind of coming up with some of these ideas around event-driven UIs and event-driven as a method of state management. So not a whole lot of great lessons that I felt the need to carry over from JSF or Swing. There's not a whole lot of prerequisites, but there are a few things that I'm going to kind of assume familiarity with when we're talking. Pretty low little stuff, just wanted to make sure we put those out there. The first thing is functions. We're going to be talking about functions, passing in data, getting data back out. Pretty simple stuff. Objects. If anyone here is like a pure functional programmer and you don't know objects, but you do know closures, that's good enough. We'll count that. Component-based UIs. This is probably like the highest level, is that this talk does kind of assume an understanding of building composable UIs from components that take parameters, have lifecycle methods, all that sorts of good stuff. C#, when I need to put code on screen, I will put it in C#. It's the one I like best, and it's my talk, so I hope you're okay with that. And then the examples are using Blazor. I think there's really only one template code example, and like Razor syntax will get you there, so there's not a whole lot of like Blazor specific stuff. Some of the things around when we're using the lifecycle methods, they might be the Blazor names, but we really tried to keep this talk high level, abstract about these ideas of using an event-driven system to manage state in the UI. So shouldn't get too deep, but if you're wondering what that code is, it's Blazor. Pure functions. So from anybody who doesn't understand what a pure function is, it's just a really fancy name for a function that takes an input, produces an output, and doesn't do anything else. And also, the same input will yield the same output every single time, which is a really nice quality to have. Makes these things like super stable, super testable, super composable. We always try to get as many of these in our software system as we can. And it turns out when we're building component-based web UIs, we have kind of a corollary, which is pure components. So these are components which take in parameters and produce web UI. Usually HTML, sometimes they'll also emit HTML, CSS, or JavaScript. But every time you pass in the same params, you're going to get the same UI back out. For all the same reasons that we love pure functions, we love pure components. They're stable, they're testable, they're composable. Can't get enough of them. Unfortunately, they don't really do anything useful as far as users are concerned. Sometimes you want to cause a side effect, like save some data, put something on the screen, download some data. You want to do something. So for that, we need to use impure components. It's illustrated here as like they have this state, but side effects are also a thing that impure components do, and part of the reason why we need them. You don't know if you're going to get the same UI out for the same parameters because that X factor of state's going to be in there. And you don't know that all you're going to get is UI. Maybe sometimes you pass in parameters, side effect comes out. So these are kind of like, just like impure functions, they're just an unfun necessity of building software that actually does things that businesses and customers value. So knowing that these are the two main pieces of components that we have to play with, kind of how do we want to build our web UIs out of these building blocks? And what I've found is the best, and I think this is pretty popular in conventional wisdom, is you want to use pure components kind of whenever possible and at the lowest levels of the tree, or in this graph, highest levels, because I enjoy confusing people, I guess. And then a very thin layer of like impure components that do the managing of the state. And if your web application just kind of lives purely in the client, if you're just doing some sort of quoting, some sort of analysis, and you don't need to do anything else, then this can be your app. This is fantastic. This is great. Sometimes, however, we have to reach across to a web service. We have to put some data there. We have to get some data out. Maybe we want to read a document out of IndexedDB, and we're going to need another piece to our web app. I call these services, some frameworks call them effects, but they're just kind of work that needs done that isn't really related to the UI, right? We're not really painting stuff on the screen. We just need to we need to go call some web service, get some data back, parse it, send it back up the chain. And so if this is the structure of your app, state management kind of happens between these two red layers here. And like that's where really your app is going to be fun and maintainable to work on, or it's going to get really unfun really fast. And so what were the ways that we were dealing with those, at least by the time I came onto the scene with building component-based applications? The first one that you learn is like state in the URL. This is how the web was built, on state in the URL. It's great for a number of reasons. It's easy to understand. This enables where like if you want to share a cool page with a friend and you don't want them to go directly to the home screen, thanks state in the URL. We want to use that because sometimes we like to deep link things. It's not a great place to put all your state, particularly if your application is pretty complex or if you have quite a lot of state. If there's things like this feature is not enabled for this user, maybe don't put a Boolean value in the URL. Sure, they could just open up DevTools and do whatever they want anyways, but we don't need to make it easier than it is. So if you don't put your state in the URL, a really popular method was to use pub sub services. At least when I started building apps in Angular, this was one of the ways that we started managing more complex state in our applications. So if we imagine that we might have a product component, which we're going to use to add some product to our shopping cart, and then some cart icon component, which needs to know how many things are in our cart, so we can put that cute little red badge in the corner. We would add a shopping cart service, and this would be kind of exposed to these two components, dependency injection for Angular, Blazor people. I think context providers is the reactive way to do that. And then when you would need to add an item to your cart, the product component would push that item, calling some function on the service, into the service's private store of data. And then the shopping cart service would expose that as a stream of state, right? Usually an observable was the easiest way to do this. But the cart icon component would then subscribe to that stream as new state got created because we're changing state, we're adding products. The cart icon component got an up-to-date number of what was in the cart. And you would typically have a handful of these in your application. You might have a user service that manages like who the current user is, if you need to display that information on the screen. You might have loyalty point services if you're gaining loyalty points for things or trying to cash those in. And these handful of pub sub services would make up your application state. Now, as applications grew more complex, we started to get quite a lot of these services, and they became difficult to kind of manage the interactions that they had with each other. Maybe when we add something in the shopping cart, we need to do something that affects loyalty points as well. And so then you started to get interconnections between these things. And this is where, I don't want to say the Redux pattern emerged, but it definitely, I think it's where it gained popularity. This is, okay, well, instead of having state spread across these numerous services, we're going to put all of our state in one place. We're going to call it the store, and we're going to use reducers to basically alter state whenever something happens. And we know something happens because an action was dispatched. So now all of our state is in one place, and we've got a continuous stream of application state. And whenever somebody dispatches an action, the reducer has everything they need to figure out what is the new state of the application, push that out to everybody who cares. And if the state that you're looking at, hopefully you're just looking at a small piece of that state. If that small piece changes, you know that you need to trigger a repaint and keep your UI consistent. So one of the reasons that I was looking for something beyond kind of these pub sub services in this Redux pattern was I didn't really kind of like how the Redux pattern and those services impacted this picture that I had built of like my beautiful, mostly pure UI that I just had like this one level of like impure. A lot of developers, basically what I noticed is we stopped passing information down to our components and started passing things like identifiers. So if you can imagine you had a product component, maybe you passed the product name, product description, cost, things of that nature, and then that pure component could render. We started doing was things like passing a product ID, and then that product component would go back to the store and get the product data from the store. And so this mostly green picture like became polluted with all this red. We had all these impure components, and every single component it felt like was participating in the store. And this led to being difficult to test. More and more components needed us to mock the Redux or NGRX store before we could test them. More and more components had a potential of breaking every time we changed maybe the way that the data was in the store. And it just led to really fragile systems, really systems that were hard to maintain and that nobody had a fun time working on. So this is a problem that I wanted to solve as I was building UIs more and more complex. But it wasn't the problem I had because I am also a full stack developer, so I had other problems as well. At the same time, on the other side of the internet connection, we were doing microservices. And by that I mean we were building lots of services, and they were small-ish. So microservices, we were doing a great job. But they kind of looked like this, in that we were good little object-oriented developers. We went and found all the nouns in our system, and we gave each noun its own database table, and then we wrapped it in a REST API and called it a microservice. So if you wanted to create a coupon, just delete a coupon, update a coupon, we had a coupon microservice for that. The problem was that anytime you had to do anything, rarely did you ever have to do it with one of the nouns. You might have been like adding a coupon for a whole bunch of products, or you might have been placing an order for a certain number of products, also applying a certain number of coupons. And so all of these services were constantly talking to each other, and they were talking to each other kind of the only way that we knew how when we got started, which was just to make web calls to everything, because everything was a REST API, so we were making web calls. This system was not very fun to work on for very long. So every time you added one of these new services, the number of connections didn't grow linearly, they grew exponentially. So every time we added one more service, it exploded in just how complex it made it. We ended up running into problems like thread pool exhaustion because all these services had to talk to each other a whole bunch of times to do anything. So you would eventually just be waiting on other people to get back to you, and then you'd run out of threads to process your own requests, and then the people waiting on you to get back to them would never hear anything. So we had some pretty sizable failures when we added more and more services for launch day. Unlike the bad feelings I was having in component-based web UIs, though, this was a well-understood problem, and we had some people we could lean on. So these are a couple of books that really helped me figure out what was going on wrong on the back end, what we were doing wrong, what we were doing to cause ourselves some pain. And then, funnily enough, I also attended a workshop at NDC Minnesota in 2019 that also really helped figure out kind of how we could make sense of that back end. I'm not going to dig too deep into it, but we'll cover it quickly because we're going to take these solutions and we're going to throw them up to the front end. So what we ended up doing differently was instead of finding all of the nouns in our system, we started to grab all of our business capabilities. And we grabbed the ones that kind of all went together and we wrapped them in bounded contexts and we gave them their own database so that whenever I asked one of these services to do something, they had all the data they needed to do it. So if I told the store I wanted to place an order, it had all the data it needed to take that order and say, yes, that order's placed. Now that order would never arrive to you because the store was never talking to the shipping service, but we're going to solve that in a minute. But the store could take the order even if everybody else was down. And so we simplified our system. We got everybody in their own little groups with their own little databases. We just needed to figure out how to get them to integrate. And the way we did that was with a message bus and events. So when you placed an order with the store would publish an event on the bus and say, hey, an order has been placed. And then other services that cared about that event would come along and they would pick it up. So your inventory service, it would want to know, hey, this order was placed, I need to deduct it from inventory. Maybe we need to reorder. Maybe I need to keep more of these on hand, we're going through them. Importantly, the shipping service would pick it up and say, okay, let's get this down to fulfillment. Let's print off a pick ticket. Let's get this shipped out to the customer because that's what they bought it for. So now the connections don't grow exponentially, they grow linearly because every time we added a new system into this ecosystem, they're only talking to the message bus in general. There were some places where you just needed real-time calls to another system, but we tried very hard to keep those to a minimum, and this is ideal. Like, everybody's just talking to the message bus. If something happens that you think is important to your system, subscribe to it. If something happens in your system that other people might need to know about, publish it. And this worked out great. Our back end got much more maintainable, much more fun to work on, much more flexible. We could be much more agile in how we delivered new features. Programming is fractal. This is an idea I got from Kevlin Henney. I really like this idea. I think it kind of cuts to really the core of what sets programming apart from other craft and engineering disciplines. We do not make big buildings out of little buildings. If you zoom in on the floor, you're not going to see a tiny little convention center. We don't make great big bricks out of little bricks, right? If you take a whole bunch of bricks, you get a building or a wall or some other structure. You don't get a big brick. But that's not the case in software. We do make big systems out of smaller systems. We hopefully make big functions out of littler functions. And we are certainly supposed to make big objects out of little objects. So this is just this great thing where, like, even if you take a small function and you zoom out and you go, okay, well, this is a web service. What is a web server? It's just a function that takes an HTTP request as an input and returns an HTTP response as an output. And so a lot of the solutions at one level of programming can be solutions at other levels of programming. And so thinking about this and how the back end got a lot simpler when we started encapsulating state and message passing, that sounded familiar to me because that's like the main promise of object-oriented programming, is that object-oriented systems are simplified by encapsulating state and message passing. And if it was true for those things, then maybe component-based UIs could be simplified by encapsulating state and message passing. And so this is where like I've crossed into heresy now. I've just told you to store local state in your web UIs, but stick with me. We're gonna get through this. So looking back at like this ideal state of what I'd really like my web UIs to look like, I would like a really big, thick tree of pure components, a very thin layer of impure components, and then a lot of like services that actually manage the application work that doesn't really have much to do with UI. And so what I wanted to put in between there was a message bus. And so this message bus is going to help me, ideally, clean up my state management by using all of the lessons that we had learned from building event-driven architectures on the back end. So in general, when you decide to solve a problem, especially if you want to solve a problem a new way, it's really helpful to kind of take a step back and understand what the problem is and why the solution that you first, the popular solution exists, because maybe it exists for good reasons. So I drew up this little graph to try and understand kind of like why front-end systems were managing state the way they were, just to make sure that I wasn't about to do something incredibly foolish. And the problem was this quadrant here, which I have labeled the quadrant of pain, because it is pain. When you have shared state and it's mutable, this is where like WPF developers will live their lives, and it's really not a great time. If you know any WPF developers, check on them, make sure they're okay. But you can't flip it completely because then you're doing nothing, and your customers and your clients don't really like it if your software doesn't do anything. Ops will love you because software that does nothing will never break and will never break anything else, but our customers at the end of the day would like our software to do some things. And so the conventional wisdom was, let's shift down on this grid and we'll share state, but it will be immutable, right? So Redux did this, NGRX, which was like Angular's fancy specific Redux, and then just observables in general with RxJS for this kind of idea that I'm going to issue new state to everybody, and when you get new state, then you can decide if you need to redraw or repaint or something, but we're not going to be changing state that other people are holding on to. And this works great for a lot of reasons, except for all of the things I didn't like about it. So what I thought was, well, what if we shift left? Right? What if we go from, okay, well, you can mutate your state as much as you want because you're not sharing it with anybody else. And the first problem that you run into is, well, if you're not sharing your state with anybody else, how does anything get done in the system? What's the integration? And it was the same integration that we used on the back end, which was to use events. So could we create an event-driven architecture out of web components the same way that we created it out of microservices? So if you're going to be an event-driven component or a participant in any event-driven system, you need three things. You need four things. I'll explain what the fourth thing is, but we're not going to get too deep into how the fourth thing works because we're going to stay high up here in theory and not dip too much into implementation. You need a subscribe function, some way of saying, I care about this event. Please tell me when this event happens. You need an unsubscribe function because we are components that may or may not be rendered at a given time, so we want to be good stewards of memory and say, hey, like, I'm no longer part of the component tree. No need to keep sending me this event. And we need a publish function because maybe something happens that we need to communicate to other people, and the way we do that is by publishing events. The fourth thing you need is a message bus, but that's kind of like what the publish function is, and like there's lots of message buses that might be available to you. If you like find a library that calls itself an event aggregator, that's a message bus. There's sometimes a message bus. And you can also get this job done with like a dictionary of like event types to functions to call when an event of that type comes in. So like that publish function kind of is like a wink, nudge, nudge, you need a message bus, but that's the function you're gonna use. If you understand the framework that you're in, and if you wanna get a little clever, you can tap into your lifecycle methods and subscribe automatically and unsubscribe automatically whenever you're initialized or disposed. So you can really cut this thing down to two things, which is a list of events you've subscribed to and a publish function. And so any examples from here on are going to assume that just by specifying the list of events, we've tapped into those lifecycle methods, we've automatically subscribed and then unsubscribed whenever we're initializing and disposing. So if you're going to build an event-driven system, you have to kind of learn to think in events and event handlers. You don't have this sort of really easy, well, I'll just go call this system and tell this system to do some work sort of thing. That's kind of how you got where I got, and I wasn't having a good time. So we need to think about how we do things. And the simplest place to start is something that just publishes an event, right? This is a contrived example. Please do not publish an event for a single button click. Hopefully that's like a form submission and like I validated the form and decided to send the data out. But the simplest place to start is just something happened that maybe I got some input from the user, maybe you got something there, publish the event. I know this says bus publish and I said there's a publish function. This is just because we typically inject objects, but if you want to inject a delegate, like that's your right as a developer, you can do it. The next step of complexity is just a one-way subscriber, just something that just listens for events and does things. So you can see how like in this hypothetical system we have our list of events that we've subscribed to is expressed as a list of interfaces. This does a couple of things. It's easy for reflection to dip in and just be like, hey, which events do you subscribe to? I can see that list there. And then it also makes sure that whoever's building this component actually implements a handle method for all the events they say they handle, right? So nicely, this won't compile if you don't handle the events that you say you've subscribed to, which is really good, and we like to catch compile time errors if we can. But yeah, so in this component, if one of these user clicked one-way publisher events gets dispatched while it's live and mounted, we will run that handle code. Stepping one time further into complexity, a real common pattern when you've got like a page that has some data on it is when you initialize, you want to go fetch the data, and then you want to come back and you want to display the data. If you're really clever or considerate to your users, you might like set some loading spinner value and then go get your data and kind of do it in that imperative like async await process. In event-driven systems, we don't sort of have that like, I'm going to sit here and wait until this promise or task completes and then go on to the next thing. We kind of have like, I'm initialized as soon as I publish that request. Someone out there is going to get that request, and then when data comes back, which is this handle method, then I'm going to copy that data over. So this is that kind of example program, if anybody's ever done like .NET New Blazor and they have like the weather service. This is that component expressed as like an event-driven component where we boot up, we say, hey, I need weather data, because that's my job, I display weather data. And then at some point later, hopefully someone has fetched that weather data. They dispatch an event that says, hey, I got weather data for you. And if you think that, hey, this isn't going to work because I didn't put a private setter on my property, I definitely did that to save space, and I'm not just noticing it now. So, all right. This is the other side of that coin, is that we have somebody actually who's the weather service whose job is to actually go and fetch this data. So the component doesn't want to know where it's getting its weather data from. It doesn't want to know which URL it's calling. It doesn't want to know what data format that's going to come back in. It's just, my job is to put weather data on the screen. I know I need it. When I get it, I'm going to put it on the screen. This weather forecast service, this is the subscriber also participating in the event system, even though it's not a component. This is going to pick up that request. It's going to do some asynchronous work. It knows which URLs to call, web services, or gRPC, however you want to do it. It knows how to get the weather data. It knows how to deserialize it, knows how to parse it. It knows how to package it up the way that our web application is expecting it. And then when it's done, it publishes this weather forecast data fetched event. Now, it might seem like I've just made this a little more complicated than it was, and I did, because if you apply event-driven concepts to a really simple idea, it's going to seem like you're doing too much. But if we think about, as this system gets built out, maybe the weather data service is not the only thing that cares about weather data being requested. Or much more likely, maybe the weather forecast component is not the only thing that cares about when weather data comes back, right? And so as more and more components and services care about these things happening, I still only have one point to get onto those events. I just subscribe to the events that I care about. Instead of having services now being dependent upon other services and trying to tap in when certain functions are called, I've kind of gotten that little bit of overhead, but now I'm into this event-driven system. So going back to our beautiful little graph that I like to draw of like how I'd like my web UIs to be built, this is just kind of an example of kind of where these things live in that architecture. So you have like the weather forecast page that when it popped up and initialized, it threw a message onto the message bus that was picked up by the weather forecast service. Weather forecast service went out, did the work, got the data, threw the data back on the message bus as a fetched event, or maybe it throws a weather data fetched failure. Maybe it can't get the data. And maybe I have a really easy way to communicate that to error components, growl components, log messages. I have a really easy way to just say, oh, I found an error, maybe I publish that. And then the weather forecast page is free just to pass that data on down to pure components who happily have no idea that any of this sort of stuff is going on. Okay, state machines. You don't need state machines to build event-driven systems, and you don't need event-driven systems to use state machines, but they work really, really well together. And I've found that they've, like, for me, they really crank up to 11, like when you've got an event-driven system. So we're going to talk about them. The reason that they work really well together is because state machines, when we're talking about event-driven systems, state machines have two qualities. And the first quality is that events are a really great way to trigger state transitions. Some event happened in the system, and that's a really great trigger for why I might move from state A to state B. The second quality is that state transitions can trigger events. So something happens that caused me to move from state C to state D, that's a really good time to spin off an event, right? I C to D, or whatever you might want to call that event. So being able to express your state as a state machine is a really natural fit for driving that state with events. Because your events are going to come in and cause your state transitions, or if your user is doing something to cause a state transition, those transitions are a really good place to spur off events. So let's do an example. This example was written up as like a fetch, like a edit data page. I'm going to talk about it like we're editing a restaurant reservation just to keep it a little more grounded in reality. My goal was to do abstract, and then I think I went a little too abstract here. So I'm going to talk about it like we're editing a reservation at a restaurant. And we've got 5 states, basically, that this page can be in. We have the loading state, which is I've just requested the page. I've managed to do a first paint, but I don't have the data. I actually want to go get the reservation that we're trying to update, right? It would be quite unhelpful if I asked you to update a reservation and you didn't even remember how many people were typed in or what time it was. You didn't even know if you were changing it or keeping it the same. So the first thing we want to do is we want to be in the state of we're going to get that data. That's going to take some time, so we have to sit in this loading state for a while and put a spinner. From there, we have 2 choices. The load could fail. Maybe we can't find the reservation you're looking for. Maybe the downstream service is down. We don't know, but it could fail, and in which case we want to move into a load failed state. This is where we'd like say sorry to the user. There's not really a whole lot of good things you can do when your downstream service is down. Hopefully it succeeds, and we move to the loaded state, in which case now we can display, hey, you've got 4 people at 10:30. We'll see you for brunch. Would you like to make any changes? We can display the text box now that has the number of people in it, the date, time picker, and the submit button. Submit button is very important because that's what's going to trigger us to move to the submitting state. The submitting state is where we go when the user's like, okay, I want 6 people at 11. I've got 2 friends who want to come, but they can't make 10:30, so we're going to try and push it back to include them. From there, the submission could again fail, right? Maybe we can't find a table to seat 6 people. Maybe we don't take new tables after 10:45. Maybe the service is down again because ops is just not having a good day. So we would want to go back to the loaded state and just kind of say, hey, we couldn't make the change you requested. We'll get you back there. Maybe try again. Sometimes errors are transit. I don't know. Or it could succeed, in which case we would move to the submitted state. We get the big green check mark. Tell the user, yes, your reservation has been updated. We've got it. We've committed it. We'll see you at 11. Right. So being able to express the state of our page or application or small component, whatever you will, like this, gives us a lot of really helpful tools as we go to put this into an event-driven system. The first thing is objects are really great ways to codify state machines. This is not a Blazor object. It's just not even really, like it's in C# because that's what I write, but this is just a real plain old C# object that expresses some of that state machine. Again, I had to save a little bit of space, but you can see how we have like the abstract class at the top that is the edit page state. We have some of the states that we talked about, loading, loaded, submitting, and then the transitions between the states. You can see they're methods on the objects. So what's nice here is, again, we're getting this really nice like compile time checking. I don't have to write a test. I don't even know how I would write a test that would verify that I can't move from the loading state to the submitting state because there's no method I could call to even try to do that. I'm just going to get a compile error from day one. So I've got this like really concise expression of how the state of this page is going to change. I've got it in like a pure C# object that I can unit test really easily if I need to test some of these. And it just kind of enforces those state transitions. So you can see how if you look in the methods too, sometimes we're using events to trigger the transitions, and sometimes we've got transitions like submit, where we're going to use that to trigger an event. So we've got our state machine. We want to drop this into an event-driven component. So this is our impure event-driven component that models this edit page being backed by the state machine. So you can see we have our state, which is local, and we can mutate it this time because I put the private setter there. And we can do that to our heart's content. We've got all the interfaces at the top, which are the events that we subscribe to. And then we've got some handle methods that are subscribing to events. We've got submit, which is presumably bound to like the submit button on the form. So we're going to walk through like kind of, you can see like there really isn't a whole lot of omitted in the actual method definitions because I wanted to show just like how concisely we can drop in a state machine into an event-driven system. So if we were to get something like the fetch data success, we're just going to do a quick sanity check that we're in the right state to receive data loaded. If we're not in a loading state, we're going to do something really loud that the developers are definitely going to hear about on Monday morning because we need them to fix that. Otherwise, we now know that we can call load, passing in the success event, and get our new state back. And the component here doesn't know what the next state in that transition is, and it doesn't really care. Like it just knows that that's my new state, and because I'm putting in that property, we're going to repaint and re-render based on that new state. And we'll see in the template how we handle that sort of state-based painting in a minute. We've got the submit method, which again, presumably is bound to some sort of submit button. So we're going to do another quick sanity check, make sure we're actually in the right state to be submitting a change to our restaurant reservation. If we are, we'll just call submit and get our new state back. And then this transition, because it's not predicated upon an event, we're going to publish an event off of it, right? So we've gotten the new data. We create this submission request. I don't know where data comes from, just assume it comes from submit. I must have forgot to put it in. We get the data out of our form, we put it in the submission request, publish that event. And then we sit in our new state, which we don't know what it is. Again, we don't care, but the state machine knows. It's the submitting state. And then for some reason, we just ask for too big of a table. At some point later, we get a submission failure. So one more sanity check, make sure we're in the right state. Perform the state transition, repaint. So there really isn't a whole lot of extra ceremony, just a little bit of glue to basically drop this state machine into an event-driven impure component. So what does that look like on the template? We know we're going to, every time we transition state, we're going to do a repaint. That's the way Blazor works. Other component-based systems have their own mechanisms for triggering repaints, but whenever you modify a property like this on Blazor, we trigger a repaint. So how do we know we're painting the right thing when our state changes? This is the big scary Blazor. If anybody's not a Blazor developer, this is, hopefully it looks a lot like HTML, like with a little bit of C# sprinkled in. We can tell that this is the edit page because it has page edit at the top, because that's all harder routing needs to be for anyone who comes from a less fun system. That's literally all routing should be. So we can see that we've just got a series of if statements because they haven't yet figured out how to put a switch statement in a component. I think we're working on that. Just checking what state we're in and then calling the appropriate pure component. You can see that there's nothing in the busy component because it's just a spinner. We don't really need to pass any data to a spinner. But also, the busy component doesn't need to know about state, doesn't need a publish function, a subscribe function. It doesn't need to slice bits off the store. It doesn't need to do any of that. We know what state we're in. We have a pure component specifically for that state. If we're in a loaded state, we have a pure component for the loaded state. And you can see here too, like I actually can't even render the loaded edit form unless I'm inside this if block because I need access to this pattern match state to get here. So that loaded edit form, pure component, super easy to test, right? Pass in my data, check the rendered HTML. Do I see the input for the number of people? Do I see the date time picker? Do I see the button? Submitted state, very similar, right? We just want to pass in that confirmation. Pure component, doesn't do anything, doesn't need to know anything. And then again, I've trimmed the rest for space, but I think you get the idea. So just going back to that graph that I like to draw of like how I lay out my UIs, just to kind of walk through that example we just saw. We had this edit page component, which started by dispatching an event to say, hey, I need to request this reservation. Presumably that got picked up by some load data service, which really quick job, querying the web API, deserializing it, packaging it back up, publishing. Then the edit page component picked up that successful, hopefully, fetch data request, transitioned state into a form where the user could enter some of data and update it. When that was submitted, we published a update reservation request, if you will, which got picked up by some update data service, takes it, knows which API endpoint to call, knows how to authenticate, knows how to deserialize the response, parse all that, publish success or failure back up on the message bus, and then the edit page component picks up that success or failure, changes state according to the instructions of the state machine, and then just picks the right pure component to display at this time. That wraps up pretty much the talk. I think I did leave a little bit of time for Q&A, and also if anybody just wants to get to the conference party a little earlier, that's all right with me too.
Do you find yourself sort of using a lot of the state has changed method and sort of, tends to, end up sort of abusing always if you like, or how do you work around it?
Yeah, so the question is, did I use a lot of state has changed calls? I did early on because I didn't really understand when I needed to call state has changed. I just wanted to make sure I was re-rendering. Blazor's pretty good if you modify one of your public properties that's bound to the template of calling state has changed on its own. So I don't really need to call that so much anymore. When I have run into performance issues, building these kind of, it seems really chatty and it seems like I might be changing a lot of stuff, it's always been I'm doing something really silly, like loading a bunch of data I don't need to display. It's never really yet been the event-driven. Now, I'm sure there are some high-performance systems that I haven't worked on. If you've got like, you know, I don't work in fintech. I'm sure those are the people who would have exactly the kind of problem where you need performance. But anytime I've seen a slowdown, it's because I'm doing something really stupid at an app level or a domain level. It's never been because of the event-driven. It's a good question. You can. So a lot of one of the cool things that Blazor can do, and a lot of other web frameworks can do this now, is kind of be hosted on the server and then just kind of push the DOM diffs up to the client. So if you're in Blazor server, your events don't necessarily need to call a web API. They can actually just talk directly to the database or whatever server thing they're talking to. But if you had a bridge between them, let me go back to, if you go back to this, so like here, this message bus, like you could build this in a way that all it does is connect to like WebSockets using something like SignalR and just passage those messages right over to your server. And then you could have your services, your service handlers just live on the server. That's definitely a way you could do that. Yeah. Any other questions?
You were showing at the beginning, like, where you went down the wrong path, where you had the noun style
Mm-hmm.
things, and then you were like, okay, cool, apply to Sam Newman's kind of book on having those separate data stores. How do you make sure that using this message bus thing, you don't do the same thing, right? Because you could, rather than, it's very easy to say, oh, tell this other thing to go and do this, or tell this other thing to trigger an event.
Right.
And do this, like you're still kind of stuck a little bit to, I hope the devs do the right thing.
Yep.
And use this for like past tense kind of events rather than just say, hey, go and do this. It's like, yeah, and you've been sending all sorts of information.
Yeah. Yeah. So the question was, you know, you've showing how I had a very unfun time with all of the RPC connections. How do we make sure that we're not putting too many messages on the bus and kind of falling back into that pattern that we didn't like? I didn't get to dig too deep into it because I wanted to keep it in the UI, but there are some good lessons when you're building event-driven backends and distributed systems. So like if you go through an exercise like event storming, where you really understand your domain events, I had that like word of warning, like don't publish an event because a button was clicked. Ideally, you want to publish an event because it represents something happening in your domain, like the user requested a change to their reservation. So understanding what events are in your business that you're actually trying to enhance and making sure that your events map mostly to those will help you avoid like having a whole bunch of senseless events coming across the wire. It can be easy to fall into that trap if you haven't gone through the exercise and understanding what are the actual business events in this system that I'm building. That's a great question. Thank you. Anybody else? We just want some extra time for the party. Totally understandable. Okay. I've got the information up there again. I will talk about this. Dispatcher was at one point intended to be a library to do this. It has since become a cookbook because it actually is just small enough for me to just re-implement every time I want to use it. But if you do want to see like, how do we build a message bus? How do we build event-driven components? There are some code examples there you can look at. It's a bit out of date. I think it's .NET 6, but should be enough to follow along. So thank you.